Okay, so welcome back. So today we're going to talk about determining asymptotes. So there are three types of asymptotes that we're going to learn today how to determine and how to find them. Okay, so just listen and make sure you're taking notes. Okay, so of course we've already talked about two of the kinds of asymptotes. We got vertical and horizontal, but there's also what's called oblique asymptotes, and we'll talk about those in a moment. But there's really easy techniques to determine if there are vertical asymptotes or if there are horizontal asymptotes and what they are, and then or if there's an oblique asymptote, what it is as well. Okay, so I'm going to go through this. There's a lot written down here, but I'm going to go through it and I'm going to explain as I go on. And again, we're going to do examples of how we do this too, so just don't worry about that. In the next video, we're going to do an example of how we find these. So I'm going to just explain it for now. So in determining asymptotes, again, we're talking about rational expressions in lowest terms. Again, it has to be in lowest terms for this to work. So for vertical asymptotes, very straightforward. If you want to find any vertical asymptotes, you basically take the denominator and you set the denominator equal to 0, and you find the solutions to the denominator, to that equation. So you basically find the zeros of the denominator. And if you find zeros in the denominator, then there are vertical asymptotes located at those lines, x equals. So what it's saying is find any vertical asymptotes by setting the denominator equal to 0 and then solving for x. And then any zero of the denominator, then x equals a. So if a is a zero of the denominator, then x equals a, x equal to a is a vertical asymptote. Okay, so let me just repeat that. You set the denominator equal to 0 and all of the zeros for that solution. So when you solve for x, all of the x values that you find, there is going to be a vertical asymptote located at that x value. Okay, now what about other asymptotes? Now, so we're going to look at now, this is where, for other asymptotes, we look at the degree of the top, the numerator, versus the degree of the bottom, the denominator. So for part A, it says if the degree of the numerator is less than the degree of the denominator. So in other words, if the degree of the top is less than the degree of the bottom, then there is a horizontal asymptote, and it's always going to be located at y equals 0. Okay, so let me repeat that. If the degree of the top, the numerator, is less than the degree of the bottom, the denominator, then you will have a horizontal asymptote at y equals 0. Okay, so that's part A. Part B says if the degree of the numerator and the degree of the denominator are the same. So what if they're the same degree? Then you will have a horizontal asymptote, but it may not be necessarily at 0. It'll be at some value of the ratio of the leading coefficients. So that's where this A sub n over B sub n come from. So how does that work? If the degree of the top and the degree of the bottom are the same, what you do is you ignore all of the terms except for the leading terms, and you only look at the ratio of the leading coefficients. The ratio of the leading coefficients will tell you where the horizontal asymptote is located. That's how you do it. Okay? C says, okay, now, we've dealt with what if the degree on the top is less than the degree of the bottom. We've also dealt with part B, where what if they're the same. What if the degree of the top is exactly one more than the degree of the bottom? Okay, what then? Well, in this case, this is where you have an oblique asymptote, or what we call slanted asymptote. Okay, so if the degree of the top, if the degree of the numerator is one more than the degree of the denominator, then we know we have an oblique asymptote. And how do you find that? You find it by using synthetic division and finding the quotient. And so when you find the quotient, that will tell you the equation for the oblique asymptote. Okay, that's it. So that's really it in a nutshell. That's how you determine the asymptote. So next time we're going to do an example and I'll show you exactly how this works. Until then, have a great day.